Hello, everybody. My name is Kyle Wanner, and I'm the Director for the North Dakota Aeronautics Mission. I want to welcome all of you to our first virtual aerial applicator safety meeting. As you know, our agency requires that the chief pilot of each licensed aerial applicator business in our state either watch this safety seminar video or attend the National Agricultural Aviation Research and Education Foundation's PASS program on an annual basis. It's also important to note that the Department of Agriculture also requires that you attend the PASS program at least once every 3 years to maintain your pesticide certification. That being said, to ensure that our office receives notice that you watched this safety seminar video to fulfill your annual requirement with us in 2021, make sure to complete the questionnaire at the end of the video. I also want to remind all of you that all of the pilots that are operating on your aerial applicator license must be listed on record in our office. And so if you have any pilot changes throughout the season, please ensure that you communicate those changes to us. Also, all aerial applicator aircraft must also be registered with our office and also listed on your aerial applicator license. So again, as the season progresses, any new aircraft or pilots working on your business must be updated on your license. You can do this by contacting our office directly via phone, email, or by submitting a revised SFN 7546 form, which is our form for requesting an aerial applicator license. As always, after your license has been approved by our office, we will return a decal and a signed receipt to you, which will become your official license certification. That license decal then needs to be displayed on each of your aircraft on the pilot side of the aircraft engine cowl. I also want to announce that we have a new licensing specialist in our office. Her name is Janelle Peterson, and she's excited to work with all of you, answer any questions that you may have, and ensure that all those T's are crossed and I's are dotted to ensure that you are set and ready to go this spring. I also wanted to mention that at some point in the near future, our office will be taking an initiative to update our administrative laws to allow the licensure of operators that would like to utilize small unmanned aircraft under 100 pounds for spot spraying. When we move forward on this issue, we will be ensuring full transparency by emailing and mailing all aerial applicators what the proposed changes are, and we'll also be advertising in all county newspapers, and we will be allowing public comment on those proposed changes to be heard prior to implementation. And so with all those things in mind, we have some great speakers in attendance for you today. And though COVID-19 mitigations prevent us from having an in-person safety meeting and an in-person conference this year, we are appreciative that technology has allowed us to make accommodations this year. And finally, I want to thank all of you for taking the time out of your busy schedule to watch this safety seminar, and I wish all of you a successful and safe spraying season in 2021.
Hello, everybody. My name is Jeremiah Lean. I'm with the North Dakota Department of Agriculture, and I'll go through a brief update of some things to look out for. So starting off, we'll talk about storage. Containers must have a proper and clear label. If it's torn or gummed up where you can't read it or missing part of it, just take a black marker, write on it safe send, and then if the inspector shows up to do an inspection, they see that it says safe send, they'll know that you plan on properly discarding of it. If they happen to do an inspection, and it's a couple years down the road and it's still there, then then there will be an issue. But store away from seed, feed, and fertilizers. That doesn't mean you need a separate building. You just need a far enough away distance so if there's a spill or a leak that it won't contaminate any of those other items. And so, don't store the pesticide above any, seed, feed, or fertilizer. And just enough distance away so it won't contaminate it. Store in a dry, well-ventilated area. Store in the original containers, and no open floor drains. So it either needs to be self-contained drain, meaning that it can be pumped out if there was a spill or a leak, or you got to plug or cap the drain. Regarding your records, this is all the stuff that's required in your records. You can make your own record form. You just have to have all the required information, which is in the next couple slides here. If you want to use a template, we do have that on our website, and I'll have an example of that coming up in a few slides here. Some things to highlight, you need to keep your records for 3 years. Fill them out for each application. They must be filled out within 24 hours of the application as well. And then a copy given to the customer unless they fill out in writing that they're allowing you, the applicator, to maintain their copy for them. Now here's an example of the template on our website. Everything in yellow can be, or is what is required, I should say. They do have PPE requirements and REI, restricted entry interval, on here. If you are using this form to complete your WPS record keeping, then that would be required. But if this is just a standard using it for your pesticide application record, everything that's in yellow is what's required. Make sure you're using your start and stop time, and also putting AM, PM, or use military time. Otherwise, you end up owning the whole 12 hours if you just put 8 to 9 or something like that. And if you do go to our website, the easiest thing, just Google North Dakota Department of Agriculture. There'll be a tab at the top that says Forms. Scroll down to the pesticide section, and then you'll see pesticide application record, and then you can print those off. Paraquat training. So before you apply Paraquat, make sure you go to this link or just type in EPA Paraquat training. I think it's one of the first ones that pop up. Run through the training. If I remember right, I think it took me a half an hour, I think, when I did it. Also, there's proposed EPA change to ban the use of Paraquat from making aerial applications. Now, that was proposed. I don't believe as of yet it hasn't been finalized, but keep an eye out for that. And then as regarding the Paraquat training, take the training every 3 years and print off the certificate at the end. Atrazine. Now that's a restricted use due to the ground and surface water concerns. And North Dakota's been doing water sampling since 2013 around the state. 30 sites, rivers and streams. I went through, it's been several years, but you go to a bridge, lower a sterile bottle down in, pull it up and collect the sample and ship it off to be tested. So in 2019, here's some, the far left has the chemical, and then the next column is the number of detections, and then the range of detections, parts per billion, and then the far right column is the lowest, I believe that stands for allowable level benchmark, I think, if I remember right. And so you don't want to go over that number, basically. And well, it'd be nice to not have it at all, of course, but you definitely don't want to go over that number. It does look like this last year that atrazine wasn't as spiked as high as it was in the previous years. I know that it was 2017, I think it was 7.6 or something like that. And that was really significant. But metachlor down there was over, and kind of puzzled on that one, not exactly sure where it was coming from or why. But anyways, here's showing you the different chemicals, and the main thing is to just be really careful, be cognizant if there's going to be the weather for runoff, that type of thing. And I know atrazine was going under registration review, and that should be wrapping up, I think, fairly soon. So I don't know, it'll be interesting to see, do they put on more restrictions, or what happens with that. But we weren't the only state that had issues with atrazine in the water. There's other states, and so it was on EPA's radar. So in the future, we'll continue to do the water sampling, monitor it. Like I said, is undergoing a registration review. I would think that would be wrapping up, like I said, fairly soon, because I think they started that several years ago, and it's a several year process. So just be really careful using that, and try to make sure it's not getting into the water. Or also, if the soils are permeable, a lot of labels will have that on there. If they have groundwater concerns, it'll say something to the effect, I'm paraphrasing, do not use this if the soils are permeable and the depth of groundwater is, say, 25 feet or less, something along those lines. The interactive B map, a lot of you've probably seen this by now, but figured I'll keep it in here and mention it. Pesticide applicators, you can create an account. The beekeepers can also create an account. You go and put in your information. Then if they set a apiary location within your watch area, you'll be notified, and vice versa. And so it's more interactive than it was in the past. They also have vineyards and organic on here. They're not required to list their locations, but a lot of them do it, so it doesn't hurt to check out. Once you click apiaries, you'll see all these dots. And then once you zoom in to your location, you can get the contact information to pop up. So if there is an apiary, you can see if they will cover the hive, move it, or at least it makes you aware that there is one there. Safe Send. And most of you are probably aware of this as well, but if not, it's a non-regulatory pesticide collection program. It's free, doesn't cost you anything. Just bring it to the collection site, stay in your vehicle, they'll take it out for you, and usually you're on your way in a couple minutes, unless there's a line, but even if there is, typically it doesn't take you too long. Don't bring in leaking containers, leaving a trail down the road and into the DOT. Repack it into something that won't leak, an impervious container, or give me a call if you need some help or some ideas on that. But yeah, just don't bring it in leaking and all over the place. I've seen some interesting stuff over the years. If you do happen to have over 1,000 pounds, let me know about a week in advance. Just send me an email if you want, or you can text or call, or however you want to do it. All I need to know is what site you're going to, and a rough estimate on what you have. So, if you're going to have, say, and I don't know how it's going to work out as far as some years we have restrictions on the amount that you can bring, depending on the budget. So, but say there wasn't any restrictions, you had 3 shuttles and it was going to weigh, say, 5,000 pounds. Just tell me that 3 shuttles, it's going to be roughly 5,000 pounds. I plan on going to Dickinson, and then I'll let the contractor know. And the reason being is so they have enough trucks there to haul it away. If you do come up with a significant amount of product and you didn't pre-register, you run the risk of being turned away if they don't have the space to haul it out of there. So we don't accept rinse-aid, and we don't accept empty containers. And again, pesticides only, herbicides, insecticides, fungicides, rodenticides, hard surface disinfectants, but no fertilizer, oil, paint, surfactants. That's another one. Adjuvants and surfactants is where I see on the ag side they try bringing in, and those are not pesticides. So collection times are from 8 a.m. to 12 p.m. local time. We have 8 core sites. They remain the same every year. And we have 4 sites that rotate around the state, and those are the same every other year. So basically 4 sites are on an even and odd year. So these are the core sites: Dickinson, Tioga, Minot, Bismarck, Devils Lake, Valley City, Ashley, and Larimore. The odd year rotating sites: Harvey, Winemere, Langdon, Hettinger. And then the even year would be Beulah, Rugby, Lisbon, and Adams. So a spill kit is pretty simple, enough absorbent material to absorb 5 gallons of liquid and enough impervious containers to contain 10 gallons. So if you had two 5-gallon buckets, a bag of floor dry to soak up 5 gallons of liquid, and a shovel, the adequate tools to collect, you'd have a spill kit. You can get absorbing pillows, however you want to handle it, just as long as they meet those minimums. And those are required where you mix and fill, and then also 50 feet of an operational area. So say if you did repack bulk tanks, anything like that, within 50 feet of that. Decontamination kit, clean water to rinse. There's and it's different for workers and handlers. I always get them mixed up. I think one is 1 gallon and the other one's 3 gallons. So clean water to rinse. A lot of people have a dedicated clean water tank and they're well in excess of that. Disposable towels, liquid soap, change of clothes, which is usually a Tyvek suit that they throw in. Eye wash if the label requires. Make sure it is just regular eye wash, not saline. Saline can bind to salts and burn your eye even worse, say like with 2,4-D. So make sure it is not saline. And if you need help with the amount of water for the decontam kit, just let me know. I can look it up fairly easy and get that to you. But like I said, usually they have a dedicated clean water tank and they're well in excess of that. And lastly, for the common infractions, the things that the inspectors see the most are personal protective equipment, not having the right equipment or not having it or not wearing it. Spill kits, decontamination kit, not having a label on site, has to be on site or with you. Financial responsibility and spraying in high winds. The label has to be on the application side, but of course you're going to be flying. So, and same thing with the financial responsibility. Here's my contact information. Like I said, you can call or text 701-425-3016. And then my email is jjlien@nd.gov. All right, thank you.
All right, greetings aerial applicators and anyone else watching this video. I'm Jakey Stoltz, Director of Operations at the Northern Plains US Test Site in Grand Forks, North Dakota. And I'm here to give the annual Aerial Applicator Safety Meeting a drone update. So I'm going to give one quick update from a national perspective and kind of a big FAA update that happened right at the end of the year. And then I'll go into a little bit of what we did in 2020 and more so just to kind of showcase things that are going on in the state and some of the art of the possible that's going on right now. And then I'll cover some of the things that we're looking forward to in 2021. So these might be things that we want you, the aerial applicator community, just to be aware of. But also maybe areas where we can just collaborate and engage with you all to make sure that we're sharing that low altitude airspace safely with you guys. So for the national update quick, right at the end of the year, 2020, the FAA released one big new set of regulations, Part 89, remote ID operations. And they made an update to Part 107. So it's kind of two big pieces of rulemaking right at the end of the year. So I'll touch on Part 89 quick. So again, this is remote ID for unmanned aircraft. And the FAA likes to call this the digital license plate for drones. So the idea is that in the near future, and I'll talk timelines in a second, but in the near future, essentially all unmanned aircraft will have to broadcast a set of information about the aircraft and what it's doing. So location, altitude, direction, speed, location of the ground control station. And really the idea here is to just increase accountability of the unmanned aircraft industry and allow for some security actions and work to be done. So this set of rules has a pretty long grace period right now. So it was published and it's going to go into effect kind of in a staggered way. So at first, drone manufacturers have about 1.5 years here to develop the technologies and the solutions to actually implement this on the drones that they manufacture. So this would be like the actual transmitters that are gonna broadcast this information, and the code or the type of messages that are going to be sent and how they're going to be sent. And then in about another year, the operators will have to actually comply with this. So basically September of 2023 is when we're really going to see this rolled out across the board. And so again, the concept is that the drone just broadcasts this information from the drone via the transmitters. So certain groups like the FAA and law enforcement will be able to receive those signals from the drone and then learn about the drone flight. Maybe they can see it or maybe not, but either way, they'll be able to learn certain information about that drone and take that and do what they will with it. The public will have access to this data in a limited way, but the FAA and the industry is very concerned about privacy, and they do want to maintain some privacy for these operators. So the public will not really have full access to this data per se. And I suppose the best analogy maybe right now for this would be how you can go look like on FlightAware and see a little bit of information about the commercial airlines that are flying around and so on. So it's not apples to apples, definitely, but just maybe a slight analogy there. So that's part 89, and that was just released. The other part, the updates to part 107. So really quickly, there's mainly 2 big updates to that. There's a couple other administrative things, but 2 big updates. So number 1, the FAA by regulation is now going to allow night operations for small unmanned aircraft. So previously you had to go get a waiver. Now you'll be able to just do it by regulation. The FAA is requiring operators to have an anti-collision light on the drone that can be visible for 3 miles. And they're requiring them to take FAA training on night operations. As long as you meet those, you're good to go fly at night. The other update is operations over people and moving vehicles will also be allowed. This one has a little bit more requirements to it though. So the FAA will approve certain solutions to enable this. And the FAA is looking for aircraft to have a certain kinetic energy level upon impact that they've figured out is safe through some of the research and impact testing that's been done. So a drone manufacturer or drone technology provider can put certain technologies in place. So for example, if the drone has a technical issue and were to come tumbling down out of control, there needs to be a technology or some sort of procedure or solution in place to make sure that if that drone hits somebody, the kinetic energy is at a low enough level that it will not seriously injure or kill them. And so I'm really kind of generalizing this concept, but essentially, as these solutions come into play and the FAA approves them, there will be certain operations and certain drones that can be operated safely over people, and the FAA will allow that. So this one has a much shorter time frame. It will go effective on March 16th of this year, and then it's really just up to the industry to submit their solutions to the FAA for approval and get those approvals to then allow those solutions to fly over people. All right, so now focusing into North Dakota, quick highlights from 2020, just again to kind of showcase what we're up to and some of the things that we're looking at. So early last year, we started an initiative to help other state agencies implement drone programs and make sure that their operators are trained, that they have policy that's robust enough to support these flight activities. And so North Dakota Department of Transportation was one of the first that we collaborated with on that. And we were able to help them develop their policy. And then we did some in-person training with their operators to, again, just to kind of share all the lessons learned and help them become safe operators using drones to do different things like bridge inspections or salt stockpile volumetrics. The DOT has a wide range of activities, and they're just trying to bring drones into the mix to do their jobs more safely and more efficiently. So that was good. Another thing that we did is we worked with North Dakota Aeronautics Commission to think through ways to enable drone aerial applicating in the state. So aerial applicating from a drone is starting to become more popular across the United States. There's a lot of operators looking at ways to use drones for aerial applicating. And so we worked with the North Dakota Aeronautics Commission to just think through some of the issues there and make sure that it's being done safely inside of the state, and we're good stewards of both the airspace and the land and the surrounding communities to make sure that these chemicals are being used properly. And aerial applicating from a drone, as we look at some of the use cases, these are actually very complementary services to what the manned aerial applicating community does. There's really not many, if at all, that we know of, at least, companies that are doing like large field crop spraying with a drone. It's just not very effective right now, both from the amount of liquid that the drones can carry, and then also some of the regulatory issues like line of sight. So actually where we see these drones being used more is for like really targeted spraying. So maybe a ditch or the shoreline of a body of water for mosquito larvae, or maybe a gravel pit. So very like targeted, kind of small area type of spraying events. So we see these activities really as complementary to what the manned aerial applicators are doing. But we're going to continue to kind of work through those and work with the Indian Aeronautics Commission to, again, make sure that we safely integrate them both from an aviation standpoint and a chemical standpoint. And then lastly, a really cool operation that we did over the summer was closer to home here in Grand Forks. So we worked with Northrop Grumman and an aircraft they call the Firebird. This is a larger UAS that takes off conventionally and operates at high altitudes, but we were able to support them in a multi-day flight. So this is actually a flight that spanned over 24 hours, and we did it beyond visual line of sight using the technology that we have here in the Valley. So it was really cool, great to see, great success. And again, just kind of shows that we're continuing to work and kind of push the boundaries of what's possible for safe integration of varying sizes of UAS in the NAS. Okay, so then what's coming up in 2021? What are we excited about and what are we working on? So one of our really big initiatives right now is a program called Vantis. And if you are going to the broader conference on March 8th and 9th, you're probably going to see another presentation about this. And if you're in the Wofford City and Wilson area, you may have actually been able to participate in some pilot and kind of community engagement events that we've been holding recently. So Vantis is the North Dakota statewide Beyond Visual Line of Sight network initiative. And we're really excited about this one. We're trying to implement different technologies and procedures to enable Beyond Visual Line of Sight across the state of North Dakota. So this is technologies like radios to enable robust command and control of drones across long distances, radars to make sure that we can see all the different aircraft that are operating in the airspace and then effectively coordinate or avoid them if needed. And then a suite of technology to sort of monitor and maintain all of this. So it's really too complicated of a project to really get in depth on this video here, but I encourage you all to get engaged with us on this. There's a lot of opportunities. Again, if you're part of the UMass conference and watching the different virtual events, there's going to be a broader conversation and presentation by the Vantis program office on this. And then there's other ways to get engaged as well. So Our initial work on this is really going to take place in the spring. We're deploying these different technologies to the Watford City and Williston area. And we're working closely with the FAA and a number of stakeholders to use that technology to do some of our first beyond visual line of sight operations on the network in that area. Then moving to another kind of cool project we have going on this summer with the Department of Homeland Security and Customs and Border Patrol. We're working on some airspace domain awareness research with them. This is going to take place primarily at the Camp Grafton South facility. And it's going to all be small UAS Part 107 low altitude operations, but we'll be doing some pretty high tempo operations in that area for a couple weeks as we help DHS and CBP research different airspace domain awareness techniques. And then finally, we're going to continue to work with different state agencies, again, to just help them develop policies, robust policies, and have well-trained, safe operators. So we're looking to work with North Dakota Highway Patrol, continue supporting Department of Transportation, and possibly other state agencies like Department of Mineral Resources, North Dakota Department of Health, and the list goes on and on. So we're really trying to work with these state agencies to safely and in a mature way kind of implement drone operations into their essentially their workflows that they're already doing. Okay, so as I close up, like always, I like to try and give some recommendations again on how we can just continue to collaborate with the aerial applicator community and safely share that airspace, that low altitude airspace that we know is kind of critical to both our industries. So, on one big thing I would just say is, feel free to engage with us, and we're going to try and engage with you as well. So we do this through a number of different activities. When we do operations that we know maybe are going to impact you in a greater way than others, we do try and do pilot outreach events, such as the events that are going on in the Watford City, Williston area this week. And we also use the Indiana Aeronautics Commission as a way to get information about maybe aerial applicators that are in certain areas that we think we're flying in. And we'll reach out to them and maybe give them a heads up on the operations that we're doing, where we might be, at what times. And this reaching out is not meant to deter any sort of manned activity in a certain area. We just want to give a heads up and try and just work closely with you and coordinate so that we can safely share that airspace. So we also found NOTAMs in some circumstances when it's maybe more advanced operations, such as beyond visual line of sight. We do file NOTAMs, and oftentimes the FAA requires us to do that. So that's a good way to also see where we're at and what we're doing. And so I think that's all I have today. Again, thanks for the opportunity. Please feel free to reach out and engage with us on any of these topics if you want to learn more, or just talk to somebody about drone operations. We're happy to help and be a resource. So with that, enjoy the rest of your UMass conference, and we'll see you next year.
Welcome, everyone. My name is Jeffrey Bull. I'm with the North Dakota FAA safety team. And today I'm going to talk a little bit about, or show you the statistics for Minnesota, North Dakota, South Dakota. And then talk a little bit about some accidents as a result of engine failure after maintenance. Kind of interesting how all these came about and how the pilots dealt with them. So let's move on. This will be keeping an eye on what we need to fix. Well, we'll see. We'll see about this. This is your nationwide accidents in the last 3 years. North Dakota, South Dakota, Minnesota. So we've gone down, and I don't know if it's COVID or not, but we only had 2 accidents through 3 states last year. which is really good. I think it's all accidents by month nationwide. July is the highest, but of course May, June, July, August are the highest because that's when most of them are in the air, most of you guys. Even I guess in the south too, but I would think they'd be able to do it all year round. North Dakota, South Dakota, Minnesota, it's pretty much the same as national. And this is over, of course, 3-year period. Accidents by phase of flight nationwide, maneuvering and takeoff are both top of the list, and top of the list for North Dakota, Minnesota, as you can see. How do we get a handle on that? I don't know. Maneuvering has a lot to deal with running into wires and poles and static equipment. So that's kind of just some of the stats. It hasn't changed from a couple of years. Still maneuvering and takeoff. And I guess now we'll go into more about what I know. Maintenance. Just kind of an overview. Why cover engine failure after maintenance? Well, because for you guys it's kind of important. Taking off with a heavy load and your engine dies, bad things happen. As well as you guys, a lot of you people work on your own aircraft or you help or oversee. So these are things that you should be aware of. Engine failures after maintenance is another way of saying maintenance error, really. And we'll just go over this. It's just a list of accidents that illustrate the most popular mistakes that cause engines to quit. Engine failure after maintenance. These are the top 10. And I was kind of surprised at the top one is cylinder torque. I would have thought something else other than that would be more common. I have seen in my career a few times where cylinders let loose. It's not always due to torque, but I'd say the majority is. Torque's over torque, lead to cracks, or under torque. And then control cables, loose B-nuts, mags, carburetors, improper installation of components, valve train, induction, loose accessories, oil filter adapters. I've seen that problems with those too. It's not uncommon. And connecting rods. Yeah, that's kind of what cylinder torque can do. It's interesting. These in my career as well. When engine controls become disconnected or jam, it is very much like an engine failure. Here are two examples on this slide. One was a Mooney on an instructional flight when the throttle cable became disconnected. And the other is a Piaggio with the clevis pin installed backwards. Oh, the Mooney 201 throttle cable disengaged when the castle nut backed off after operating without a cotter pin installed to secure the nut. A CFI and a student pilot were practicing instrument maneuvers about 1,500 feet mean sea level when the engine stopped responding to throttle control inputs and producing enough power to maintain flight. They chose to conduct an off-airport landing in a field which substantially damaged the fuselage and wings. Following the accident, one of the airplane's owners inspected the airplane before the wreckage recovery. He removed the engine cowling and found a bolt and nut resting on the bottom of the cowling. He also noted that the throttle arm linkage was not connected to the throttle body arm. He reported that the throttle linkage was found in the full forward position and that the throttle body arm was found in the low power setting. He asked an individual to move the throttle control in the cockpit and noted that the throttle linkage moved, but that the throttle body arm did not move. A post-accident test run of the engine was performed following the replacement of the bolt that connected the throttle cable to the throttle control arm, and no anomalies were noted that would have precluded normal operation. A review of the maintenance logs revealed that the most recent annual was completed on 15 April 2013 at a recorded TAC reading of 5276 hours. The mechanic who performed the inspection reported that all engine control cables were checked and lubed and that the throttle control linkage bolt nut and cotter key were in place. The most recent engine maintenance was performed 6 days and 1 flight hour before the accident by the same mechanic. During the maintenance, the starter was removed, overhauled, and reinstalled in the engine, and no maintenance was conducted in the area of the throttle linkage and throttle body arm. It is likely that during maintenance at a previous undetermined time, the cotter pin was removed from the throttle linkage bolt and nut and not reinstalled. The nut then gradually loosened and fell off, which allowed the bolt to become loose. The missing cotter pin should have been detected during the most recent annual inspection or engine maintenance. Now, I'm not saying this maintenance individual was lying, but when you do an annual inspection, are you going to remember specifically everything that you've done when you get asked, oh, and what are you going to say? Well, you get asked, well, was the cotter key in that nut? And that causes failure? You're not going to say, well, no, I didn't put it in there this time. Too big of a hurry. Of course you're going to say, yeah, it was in there. I mean, if you have a cotter nut on there, the only reason it's going to fail normally is if your bolt is in bad shape and chafed or fractured or something and it breaks. It won't back out of there. Anyway, the probable cause, NTSB, the improper installation and inspection of the throttle linkage by maintenance personnel, which resulted in the throttle linkage coming loose and a subsequent partial loss of engine power. You know, I'm pretty sure that when you lose a throttle, I guess I can't say for sure. I thought they went to full power. It's been too long since I've been dealing with that. B-nuts. B-nuts cause all sorts of trouble. They fasten tubing that contains fluid under pressure, sometimes flammable fluid or delicate sensing pressure. These are excellent reasons to make sure B-nuts fit tight and are tight. The idea is to finish a job or unfasten the connection, and obviously unfasten it, not just leave it hand tight or leave it on the flare. It takes a while for a B-nut to vibrate loose, and that may well provide time for a pilot to, well, of course, get up in the air or get well into his flight before things go wrong. We'll give 2 examples of how B-nuts took pilots where they didn't want to go. A helicopter, Bell 206, had landed on an offshore oil platform and was refueled. It then took off with 1 passenger. Shortly after lifting off, the pilot heard a loud pop as the nose of the aircraft passed over the edge of the helideck. The noise was simultaneously accompanied by illumination of the engine out warning light, and a needle split indication was observed on the engine and the rotor tachometer gauge. As the aircraft yawed and lost climb performance, the pilot lowered the collective pitch full down and activated the floats. Upon landing on the water, the aircraft rolled left until inverted. The helicopter was later recovered and the engine disassembled and examined. The only anomaly noted was a loose PC line, which would cause a loss of fuel flow and subsequent loss of engine power, down to or below idle. It was determined that the torque required to realign the B-nut would be between hand tight and 27 inch-pounds. The required torque is 80 to 120 inch-pounds. Torque values on the other airline fittings between the power turbine governor and the fuel control were found to range from 55 to 85 inch-pounds. A review of the engine maintenance records revealed that 36.7 hours prior to the accident, the turbine module was completely disassembled and overhauled. This would have required the removal and reinstallation of the PC line. Magnetos are supposed to be redundant systems, but a fault in one magneto can cause an engine to run very poorly. The Piper accident occurred because the right mag fell off. The person who installed it didn't torque the attachment. This is not precisely a magneto issue, but it is surprising how often loose mags cause problems. The engine probably did not run well before the mag fell off. Probably not, yeah. The Cessna accident occurred because maintainers used a drill bit as a timing pin and then turned the engine with the bit installed, breaking it off. The NTSB doesn't mention why the drill bit caused the engine to quit, but it may have caused a crossfire that caused the engine to run poorly. So on the Piper, let's see, where is the Piper? During the cross-country flight, the pilot and passengers smelled something burning. Smoke began to fill the cockpit and the oil pressure dropped. The propeller then oversped and the engine seized. In the ensuing forced landing in the dark, the airplane struck trees and impacted a ditch. The engine was covered with oil and the right magneto was found hanging by spark plug wires. The separation of the right magneto from the engine allowed the engine oil to escape, causing the engine to seize. The magneto had been installed in the airplane about 7 hours before the accident, as we said. The mechanic who had replaced the magneto could not recall if he had torqued the magneto attachment nuts. It is likely that the right magneto attachment nuts were not torqued properly and came loose. Yeah, very likely. Probable cause and findings: the mechanic's failure to adequately torque the right magneto attachment nuts, allowing the right magneto to come loose, which allowed engine oil to escape, causing the engine to seize. So, on the next Cessna, the ATP rated pilot reported after an en route stop he planned to continue his cross-country personal flight. The pilot reported that during takeoff and as the airplane was between about 20 and 30 feet above the runway, he felt the engine surge and it then lost power. The airplane was traveling too fast to stop on the remaining runway and it impacted a ditch at the end of the runway. Examinations of the airframe and engine revealed that the left magneto was malfunctioning. During subsequent examination of the magneto, a section of a drill bit, approximately the diameter of a timing pin, was found inside. A review of maintenance records revealed that the left magneto had been replaced 15.6 hours before the accident. A review of engine monitor data revealed that the exhaust gas temperature spiked 3 times. 2 of the spikes were attributed to the before takeoff mag checks. The third spike occurred during the takeoff and just before a power reduction. This data is consistent with the left magneto failing during the takeoff. The accident is consistent with maintenance personnel improperly using a drill bit as a timing pin to time the magneto before installing it on the engine. Maintenance personnel likely rotated the engine while the drill bit was in the magneto, which resulted in a section of the drill bit then breaking off and eventually causing the magneto to fail. Probable cause: loss of engine power due to malfunctioning magneto. Can't seem to say it. Magneto. Contributing to the accident was maintenance personnel's improper use of a drill bit instead of a timing pin during magneto installation, which resulted in a section of the drill bit breaking off and ultimately to magneto failure. Magneto's ignition. Here are 2 examples of ignition issues other than caused by magneto, but still just as dangerous. Both aircraft had spark plugs blow out of their engines, causing them to quit. On the Cessna 152, the student pilot conducted 2 takeoffs and landings without incident. During initial climb, after the 3rd takeoff, he heard a loud pop, and the airplane started to vibrate severely and lose engine power. He executed a forced landing to a nearby field. The airplane landed hard and nosed over during the landing roll. The examination of the airplane revealed that the lower spark plug from the number 2 cylinder and its associated threaded insert were missing. The threads in the top portion of the spark plug hole were stripped, and only the bottom 3 threads remained. No other engine anomalies were observed. The engine maintenance logbook indicated that 7 days prior to the accident, numbers 1 and 2 cylinders had new thread inserts installed in the lower spark plugs holes. Probable cause and findings: the inadequate installation of the threaded insert in the number 2 cylinder spark plug hole by maintenance personnel, which resulted in a loss of engine power during initial. Carburetors are complex little machines. They are also single points of failure. While they seem very simple, there are critical dimensions that require special tools and documentation to achieve. Cessna 182. Shortly after leveling off and beginning the cruise portion of the cross-country flight, the engine lost all power. The private pilot and owner performed a forced landing on a highway. However, just before the landing flare, the airplane's vertical stabilizer struck a power cable and partially separated from the tail cone. Post-accident examination of the engine revealed that the carburetor drain plug was missing. The pilot stated that he had flown the airplane using automotive gasoline about 2 months before the accident. When the engine was subsequently difficult to start, the pilot removed the carburetor drain plug to purge the system of automotive fuel. He stated that he did not use safety wire to secure the plug after performing this operation. Maintenance personnel examined the carburetor after the pilot reported that the engine was running rough, about 2 months before the accident, and again during the airplane's annual inspection, about 1 month before the accident. Although maintenance personnel reported that on both occasions the drain plug was secured with safety wire, physical evidence suggested that the drain plug had never been secured with safety wire. Because of the contradictory statements and inconclusive evidence, it was not possible to determine who was responsible for the unsecured drain plug. Probable cause and findings: The total loss of engine power during cruise flight due to the missing carburetor drain plug, which had not been secured with safety wire. Yeah. 2 examples. First up is a Piper PA-28. The pilot reported that after advancing the airplane's throttle to full power for takeoff, the engine produced normal thrust. The airspeed reached 60 miles an hour and the tachometer indicated 2,700 RPM. The acceleration was smooth and all indications were normal when the airplane reached rotation. About 600 feet above ground, the airplane's nose began to lower. The airspeed remained 60 and the tach indicated 2,000 RPM. The pilot pitched the nose down to prevent a stall and ensured that the throttle and mixture controls were full forward and that the electric fuel pump was on. He reported to the air traffic controller that the airplane's engine was not producing sufficient power and that he was returning to the runway. Shortly after the radio transmission, the airplane impacted terrain and a tree. An examination of the airplane's engine revealed a fuel stain on the carburetor inlet, indicating that the airflow through the carburetor had been decreased. The carburetor induction air inlet duct was single thickness scat type ducting, which was not the material described for the part, which should have been installed in accordance with the manufacturer's service bulletin. The material appeared to be beyond its normal service life, with frayed edges, loose strings, and most of the wire was loose and separated from the duct. Further, the carburetor air inlet duct appeared to have been compressed due to negative air pressure during high engine RPMs, which would have restricted the airflow to the engine and reduced the engine power. The number 2 cylinder and its associated spark plugs contained dark sooting, likely due to the restricted airflow, which resulted in a rich fuel-air mixture inside the cylinder. The airplane was 12 days overdue for an annual inspection. The improper damaged air duct could have been identified during the inspection. So probable cause and findings: a partial loss of engine power after departure due to the collapse of the carburetor air inlet duct, which restricted the airflow to the engine. Contributing to the accident was the overdue annual inspection and the installation of the improper air inlet duct. So that's another. I've seen some pretty ratty ducting come in on aircraft, and a lot of people don't want to replace it because it might cost them money, but my gosh, it can ruin your day. Talk about the champion. The pilot reported that the airplane had climbed to about 900 feet above ground level after takeoff when the engine experienced a total loss of engine power. The pilot initiated a turn back toward the airport. While on final approach, the airplane stalled and collided with a fence. A post-accident examination of the engine carburetor revealed that a large piece of foam from the air filter element was lodged in the venturi of the carburetor. A review of the airplane's logbooks revealed that an air filter element was installed during the engine overhaul 31 hours before the accident. It is likely that the filter was installed incorrectly, thus causing the air filter element to become dislodged and drawn into the carburetor venturi. Possible cause and findings: the total loss of engine power due to the improper installation of the carburetor air filter by maintenance personnel, which resulted in the filter becoming dislodged and obstructing the carburetor. Contributing to the accident was the pilot did not maintain adequate airspeed during the forced landing, which resulted in an aerodynamic stall. So we've covered a mag that fell off. Here's a more subtle case of a loose accessory. It is a loose vacuum pump. It does not look very loose, but it's loose enough to pump the engine oil overboard. It was on a Blanca. The airline transport pilot was conducting a local flight and had been airborne for about 40 minutes when he heard a bang. The engine then began to shake and experienced a total loss of power. The pilot conducted a forced landing, and the airplane impacted a stand of pine trees before coming to rest. An on-site examination of the airplane found oil on the underside of the airframe and the back of the engine, with no oil showing on the dipstick. Additionally, the nut securing the engine vacuum pump appeared loose. Disassembly of the engine found only a small amount of oil in the engine sump, as well as numerous metal pieces. The crankshaft number 5 rod journal exhibited heat damage, and the connecting rod had separated from the journal, consistent with the lack of oil lubrication. A review of the engine's maintenance records revealed that the engine had accumulated about 263 hours since overhaul. The records also indicated the vacuum pump was replaced and had accumulated 1.19 hours at the time of the accident. The accident is consistent with the loss of engine oil from the vacuum pump drive, likely as a result of maintenance personnel improperly securing the vacuum pump following replacement. Probable cause and findings: maintenance personnel's failure to properly secure the vacuum pump, which resulted in loss of engine oil and the subsequent total loss of engine power due to oil starvation. Oil filter adapters. Engine oil adapters, if they are installed improperly, can cause the engine to pump oil overboard. It is common enough that we have two examples. The first is this Bonanza with a crushed fiber gasket, and the second is a Beach P35. We'll go over the Bonanza. During cruise flight over open water, the airplane experienced a total loss of engine power, and the private pilot ditched the airplane. Subsequent examination of the engine revealed that the oil filter adapter was loose and the fiber gasket was torn and partially extruded. Because of these conditions, oil leaked from the engine, which led to the failure of the number 2 and number 4 connecting rods due to lack of oil lubrication. The oil filter adapter was not original equipment on the engine. It was installed under a supplemental type certificate, STC, which required that the oil filter adapter fiber gasket be replaced any time the oil filter adapter was removed from the engine and reinstalled every 300 hours or 3 years, whichever occurred first. Maintenance records indicated that the oil filter adapter was installed about 4.5 years before the accident. No other maintenance entries or records pertaining to the inspection of the fiber gasket was noted during the 4 years before the accident, and no record concerning the installation of a new oil filter adapter fiber gasket was located. The probable cause by the NTSB: a total loss of engine power due to inadequate maintenance of the oil filter adapter, which resulted in an oil leak and subsequent oil starvation to the engine. And I don't see anything on the other Beach. Well, we'll go on. Oh, connecting rods. This situation seems to be a straight up mistake. It is one reason we ask someone else to inspect our work, which is a great idea. One of the rod cap bolts did not have a cotter pin installed in the castle nut. And this is on a Luscombe. The pilot reported that he had noted the engine oil temperature rising during cruise flight. He elected to reduce power and fly to the nearest airport. While en route at an altitude of about 1,000 feet above ground level and a distance of 4 miles, the engine experienced a catastrophic failure. The pilot landed the airplane on an open field. However, he could not stop the airplane on the remaining surface, and it impacted 2 trees in a wooded area beyond the field. Excuse me. A post-accident examination revealed that the number 2 cylinder piston connecting rod had separated from the crankshaft. One of the bolts securing the rod cap was missing. The bolt and nut were recovered from internal engine debris. However, a safety cotter pin necessary to secure the bolt was not located. About 20 engine operators operating hours before the accident, all of the engine's piston connecting rod bearings and their respective bolts and nuts were replaced. Thus, it is likely that at that time one of the 2 nuts was not properly secured with a cotter pin on the number 2 cylinder piston connecting rod, allowing the nuts to slowly unthread over time. Probable cause and findings from the NTSB: maintenance personnel's improper installation of the number 2 cylinder's connecting rod, which resulted in the disconnection of the rod and a subsequent loss of engine power. So we've gone over the top 10 causes of engine failure after maintenance. Cylinder torque, I guess I'm still surprised that that's the number 1, but I have seen it. Very important also on cylinder torque, or any torque, but wet or dry torque, very important. Is it a greased? Do you torque it with grease on the threads or dry torque? Such a difference. Make sure you know the difference. Engine controls, yeah, always look for that cotter key. B-nuts, mags, carbs, valve train, induction system. Induction system important. Make sure you're up to date on all the SBs, ADs for induction systems. Loose accessories, oil filter adapters. Yeah, I've seen problems with those, and connecting rods. But thanks for attending. Hopefully next year we'll see you in person, and we won't have masks maybe, and well, let's just say it'll be 45 to 50 degrees in February, because lately it hasn't been very acceptable in my world. Although it did get above 0 today so far, and it feels wonderful. Don't forget to use FAAsafety.gov or FAA.gov if you're looking for answers to questions, possibly answers to questions you don't even know you want to ask. There's a lot of information on there. You can always throw me an email, Jeffrey, JEFFRY.R.BOE at FAA.gov, and I'll try and answer them all, answer questions, look up information. I hope to be getting out here sometime. Right now it's kind of mission critical travel, and for some reason the FAA safety team isn't mission critical. So, but hopefully get out there soon. You guys take care, and see you later.
It's taken a century of advances in science and technology to enable farmers to successfully balance natural resource preservation with explosive growth in food production, reliably supplied.
We're not out just, buzzing the field and spraying. There's some serious hardcore science and technology that goes into this.
We have people who are innovative and they come up with the products that keep us in business.
After World War I, America got busy finding new peacetime jobs for the relatively new technology of aviation. And it wasn't long before the airplane found work in food and fiber production.
Those guys had some grit and perseverance to fly grossly underpowered airplanes and fly at low level without the state-of-the-art technology that we have today.
Through the mid-20th century, ag aviation grew to become a staple tool in agricultural production. Today, farmers rely on ag planes not only for fast and efficient crop protection, but also for application of plant nutrients and the seeding of cover crops critical to modern soil conservation.
We don't want to just spray the crops. We want to take care of those crops.
While the world population has increased 77% since 1980, total land used for farming in the U.S. is about 12% lower today than it was 40 years ago.
These advances are what keep us as an industry alive. That is why we're here. We change with the times.
In today's high-tech society, how can you continue to exist unless you're embracing that high-tech and unless you serve a very important purpose?